If your multi-threading requirements are very simple, you can very easily make any for each loop into a multi-threaded equivalent by using the parallel class. A parallel for each loop will automatically divide its iterations into separate threads. To begin this lesson, open the Mathland project from your sample files folder. And open the code behind file of primes.aspx. Now remove all of the existing threading code. That's everything from the first thread pool to the end of the while loop. You're going to replace this code using the parallel class. First, add the following code in the space that the code you removed occupied. Calculate primes, new int, 2, maximum value. This code simply calls the calculate primes method normally. Next, you're going to add some more code to implement multi-threading using the parallel class. In the calculate primes method, replace the line for int counter equals current value, counter is less than int max value, counter plus plus, with parallel.for current value, int max value, counter, lambda, begin curly brackets, bool is prime equals is number prime counter, if is prime, prime numbers dot add counter, end curly brackets, end brackets, semicolon. It's important to note that the code now ends with an ending bracket and a semicolon. This parallel for loop will do exactly the same thing as the for loop that it replaced, but it will automatically split the loops into separate threads. As you can see, the parallel.for method uses a lambda expression in a very similar way to LINQ code. If you prefer, you can replace the lambda expression with an action object, like the one that you used in Lesson 3.4. You can also use the parallel class to create multi-threaded for each loops. Creating parallel.for each loops is very similar to creating parallel.for loops. Imagine that you have a list collection called My Collection. The following code would create a parallel for each loop to iterate through and display every item in the collection. Parallel.forEach string, my collection, my item lambda, response.write my item. Here's how the code would look as a standard for each loop. For each string my item in my collection, response.write my item. Unfortunately, the parallel class doesn't offer a while method. If you want to make a while loop into a multi-threaded loop, you will first need to convert it into a for loop. It should be possible to convert any while loop into a for loop. For example, imagine that you have the following while loop. Int counter equals 0, while counter is less than 100, counter plus plus. Here's how this code would look as a parallel for loop. Parallel.for, 0, 100, counter, lambda. Test your code now by viewing primes.aspx in your web browser. When the page appears, click Calculate primes. This time, the calculation finishes in just 9 seconds. That's even faster than you saw when using 4 threads in Lesson 3.7. The parallel class works more efficiently because it uses the same framework as the task class, which you worked with in Lesson 3.4. The best thing about the parallel class is that it automatically prevents race conditions. The parallel.for loop will not continue until all of the threads that it creates have finished running. Close your web browser now and close Visual Studio. You've now completed Lesson 3.10. Implement multithreading using the parallel class.